During these next several videos, we're going to learn about different astronomers of modern times who took this heliocentric idea of the solar system and really solidified it with more observations and more data. We're going to start with Nicolaus Copernicus. But before we start, I thought I would throw a little trivia question at you. For those of you who like trivia, what does Nicolaus Copernicus have to do with the periodic table of elements? Think about that, and I will tell you at the end of the video. Nicolaus Copernicus was known as the father of modern astronomy. His groundbreaking contribution was to solidify the heliocentric view of the solar system after 14 centuries of Ptolemy's geocentric view. He's credited with ushering out the old geocentric astronomy, and he was a strong believer of the heliocentric solar system. He also had the audacity to believe that the Earth was simply a planet. Now you may be thinking to yourself, well, these two concepts are just steps forward, understanding our solar system, not that big of a deal. These were very controversial ideas given the religious beliefs and the religious powers of the time. The Earth was believed to be divine, unique, and placed at the center of everything by a great creator. The idea that the Earth was just a planet and not in the center of everything went against these beliefs. Copernicus was born in 1473 in Royal Prussia, an area that was part of the Kingdom of Poland during the European Renaissance. His Polish father was a merchant, and his German mother was the daughter of a wealthy merchant. His father died when he was quite young, around the age of 11 or 12. His mother's side of the family then saw to his education. He went to the University of Krakow in Poland. He was the youngest of 4 children. He never married and is believed to never have had children of his own. In addition to being an astronomer and a mathematician, he also obtained a doctorate in canon law. He was a physician. He was a classic scholar. He was a translator, a governor, a diplomat, and an economist. Apparently, he could speak 5 languages. He derived a quantity theory of money, which is a key concept in economics, and also formulated an economic principle that later came to be called Gresham's Law. His famous contribution to astronomy, which is where our interest lies, was from his famous book on the revolution of celestial orbs, which was published in 1543, which, if you recall, if I go back, was the year he died. This is a figure from his book, and it shows his drawing of the solar system. Here in the middle, we have Sol, or the sun, followed by orbiting planets, Mercury, then Venus, then Earth with the moon going around Earth, Mars, Jupiter, Saturn, and then the orbital sphere of the stars. Apparently, he had these ideas formulated for a good 20 years before his death, but he was afraid to publish them. He was worried about scorn from his colleagues, his friends, and also from the government and the church. In fact, he dedicated the book to Pope Paul III, perhaps fearing religious opposition. He died at the ripe old age of 70, apparently from what we would today call a stroke. There's a story that goes like this. He was on his deathbed and apparently finally brought a printed copy of his book. He woke briefly from his stroke-induced coma, looked at the book, closed his eyes, and peacefully died that day. Is it true? I don't know. Sounds like a good ending. After his death, his ideas were given additional mathematical support by 3 astronomers, Tycho Brahe, Johannes Kepler, and a bit later, Sir Isaac Newton. All of these scientists we will learn about in our next few videos. All right, are you ready for the answer to our trivia? Element number 112 is called Copernicium, and it's named after Copernicus. It's one of those unstable elements that don't really exist except in the laboratory. And it was first created in 1996 in a German laboratory, and they decided to name it in honor of Copernicus, as the quote says here, to honor an outstanding scientist who changed our view of the world. Our next scientist is Tycho Brahe, a precise measurer and a careful celestial observer.